Hello, Math 3. I'm going to work through some of your review problems here, well, all of your review problems here, and hopefully help you guys review for your test. Okay, so I have my log rules here in the top right. Probably only the third one will really apply for these guys, but we still look at all of them. Okay, so log base 4 of 2, right? Remember we say, okay, we're trying to simplify this. We can set it to x and solve for x. Right, so we're trying to simplify 4 to the x equals 2, right? Because we know that if I have log base b of a equals c, that is the same statement as b to the c equals a, right? So 4 to the x equals 2. Well, I want to write these with the same base, right? So 4 is a power of 2, right? It's 2 to the 2 to the x. And 2 is really 2 to the first, right? So this means that we have 2 to the 2x equals 2 to the first. Therefore, 2x equals 1, x equals a half. We could say 2x equals 1, right? Because if the base is the same, these powers here must be the same. Okay, so x is just a half. Second guy, we're going to do log base 27 of root 3, right? So again, we're going to say this equals x, and I have 27 raised to the x. 27 to what power equals root 3? And anytime I see a 27 one of these problems, right, it's a giveaway that I'm probably going to want to put things in with the base of 3, right? So this is going to be 3 to the third, not 3 times 3, 3 to the third to the x. And then root 3, right, we know that that's just 3 to the half. Right, so similarly, just like above, right, we're going to get 3x equals a half, or x is a sixth. Okay, so that's that answer. Here's a half. Let's walk through number 3 over here. Okay, so that's log base 5 of 1 over 5 root 5. Well, that means 5 to the x equals 1 over 5 root 5. And quite clearly, we're going to want to write everything in terms of 5, right? So we have 5 to the x. And then what is this thing really? This is 1 over 5 to the first times 5 to the 1. Oops. Started writing root again. 5 to the 1 half. Well, that's just 1 over 5 to the 3 halves, because we would add, right? And if I have 5 to the 3 halves, right, we're going to want to make that something in the numerator. And remember, a positive exponent in the bottom is a negative exponent on top, or a positive exponent up top is a negative exponent on the bottom, right? So this is really 5 to the negative 3 over 2. So therefore, I just know that x has to be negative 3 over 2. 4, here we're going to have to use a log rule here. So I've got log base 6 of 36 to the 45th power. Yikes. Well, 2 ways I can approach this. I'm going to use this rule up here and move that 45 to the front. I'm going to move the 45 to the front and say, okay, well, this is 45. Log base 6 of 36. And let's sort of ignore that 45 now and just consider this last bit. Just consider this bit here, right? And remember, that's really saying 6 to what power gives me 36? And of course, that answer is 2, right? But if I'm just trying to simplify that, that means 6 to the x equals 36, right? Or x equals 2. So this is going to be 45 times 2, and that's 90. 90 would be my answer. Okay. Let's move on to my natural logs here, which might concern some of us, but it's just log base e. Just log base e. Okay. And similarly, we're going to want to move this 3 in front, just like what we just did, right? So we're going to say this is 3 times natural log of e. And what is the natural log of e? That says e to what power gives me e? And well, of course, you say that's just 1, right? Natural log of e is 1. Natural log of e is 1, right? So this is just 3 times 1, or 3. And remember, if you're confused about what natural log of e is, right, just remember log base 10 of 10 is 1. Log base 3 of 3 is 1. Log base 75 of 75 is 1. So log base e of e should be 1, right? Those sort of all go with the same rule. Okay? The first, number 6. Funny that I have 2. 2 ways to go about this guy. We could either move the exponent back into the e, or I could just sort of be kind of sharp, okay? So I'm going to move the exponent back up, right? So the opposite of that last one, I'm going to move the exponent back up. And we're going to say, okay, well, this is really ln root e squared. What is root e squared? Well, root e is just a number. When multiplied by itself, it gives me e. So I'm just going to be left with ln e, which is just 1. Okay. Let's move on to the next number 6. Now I'm bothering myself with this. Okay, the next number 6, which is log x plus log x minus 3 equals 1. Okay, and now we're going to want to go back up, and we're going to want to use that first rule here. And we're going to want to combine the logarithms on the left, right? And if we have addition there, we're going to multiply, of course. All right. So what is this? This just means log of x squared minus 3x equals 1. Well, it's an implied 10 here, right? This is an implied 10 down here. So that means, again, right, we'll have this rule that we have to apply over and over and over again. If I have log base, is not a negative. Not negative here. Oops. Log base b of a equals c. That means, so we're going either way, b to the c equals a. So what does this mean? That means 10 to the 1 equals x squared minus 3x. Or now I want to treat this like a quadratic because I have x squared minus 3x minus 10. Okay, let's factor it. All right. You guys, again, should have done all of these problems already. All right, so I'm going to get 5 and negative 2. But notice if I were to plug in negative 2 back into my original equation, it would make this log of negative 2, which of course we cannot have, right? So the answer is only x equals 5 because negative 2 would make that thing negative. We could have a situation where both answers worked, right? We just can't ever take the log of a negative number. Okay. Number 7 is very similar. Log base 6 of x plus log base 6 of x minus 5 equals 2. Well, we're going to want to combine the left, right? Combine the left, so that's going to be x times x minus 5 equals 2. And what does this mean? This means 6 squared equals x times x minus 5. Or 36 equals x squared minus 5x. Get 0 on a side and factor. Right, so we'll get 9 or negative 4 here. And of course, the negative 4 will again make this thing negative here. So it's just 9. Right, again, you could have no solutions, one solution, or two solutions with these problems. Doesn't mean that we can't have two answers just because these two had one that didn't work. Okay, let's keep rolling along. Hopefully I numbered this next one 8. Ooh, my true false friends. Have to think about these things. Okay, well, the first one, well, that's just a rule, right? That's just a rule. That's just true, right? That's just true. That's just a rule. That's rule number 2, I think that we normally say. Rule number 2 in the way we normally order them. The second one, log base b of a over log base b of c equals log base b over a over c. Well, this one, if we think about it, it looks kind of like a rule, right? It looks kind of like a rule, but the question is it always a rule, right? Is it always true? And the answer is no, right? We can't just divide those things. So if we wanted to think of a counterexample, let's think. Let's use log 4 and log 2, right? So false, let's use log 4 over log 2 base 10, of course, right? And this thing is not going to be what we want it to be. I think this is actually just going to be 2, not log of 4 over 2, right? So we're saying, does this equal each other? You can punch that into a calculator. It is not going to equal each other. This is my false counterexample. C is kind of tricky, okay? C is true. It's just a rule, right? We're taking that exponent 1 over y and moving it out to the front. Okay, so that's C. D looks like a rule. D looks like a rule. Right, we have this log base 5 of 5x equals 5 log of 5x, or log base 5 of x. Right, is this a rule? No, right? If we wanted to take this guy, we could move it up into the exponent, right? But it doesn't equal 5x, it equals x to the 5th. So I'd say this guy is false as well. And then my last friend. Woo, that's fun. Log base b of ab to the t equals t log, we're saying, is this equal? Let's play around with this and see if it is. Okay, so this thing on the left, we can move the exponent out to the front. And then what can I do with this AB? I can split it up. So I can say this is t times log base b of a plus log base b of b. And what is t times log base b of a? We have no idea. But what's log base of b? We just talked about that. That's just 1. Oops. Plus 1. And you'll see that if we distributed this t, we would, in fact, get that original thing on the right. So this is true. Kind of a fun one. Maybe we'll see it again. Okay, let's move on to 9. 9, we're going to talk about log base x of 27 equals 3 over 2. So what does that mean with our log rule? That means that x to the 3 halves equals 27. Okay, and there'd be sort of 2 ways of doing this. Okay, we could square both sides to start, and then take the cube root, or we take the cube root of both sides and then square it, or we could just take it to the 2/3 both sides right now, which is what I'm going to do. Well, this side on the left is just x, right? Because we multiply those exponents, it would just be x to the first. On the right side, we're going to have the cube root of 27 squared. The cube root of 27 squared, which this might be a little tricky, okay? This might be a little tricky, but if I wanted to break this into a series of 3s, right, this is really 3 to the 3rd squared, right? And I think you guys can see that if I were to list all this out, right, I'm going to get 6 3s in there. 6 3s in there. This would be 3 times 3 times 3 times 3 times 3 times 3. If I have that many 3s in there, and I'm saying, what would I need to multiply by to get this many 3s if I wanted to multiply it by itself 3 times, right? Well, of course, there'd be 1 set, 2 sets, and 3 sets, right? So this is just 9. Just 9. It's a little tricky, but you guys can do that. And then lastly, log base x of 7 equals negative 1/2. So that means x to the negative 1/2 equals 7. Okay, so I'm going to want to get this x to just be to the power 1. So what am I going to have to multiply by here? I'm going to have to multiply this negative 1/2 by negative 2. So we're going to raise everything to the negative 2 here. And of course, then we'll have x on one side, x to the first. And on the right side, we'll have 1 over 7 squared, which is 1 over 49. Okay, let's maybe look at 11. Oh, did not have my graphing calculator because my son has run away with it. So what interest rate would be needed to double an initial investment of $1,000 over 6 years if interest is compounded annually? Okay, well, this is going to be tough for me. I guess I can type it into the computer here. So we're going to use A equals A naught times 1 plus R to the T for the annual one. And so what's that going to be? That's going to be 2,000 equals 1,000. That's how much we started with. Times 1 plus R to the 6th. Okay, so we divide by 1,000. We get 2 equals 1 plus R to the 6th. Okay, and then I'm going to raise each side to this 1/6 power. The right side is just going to become 1 plus r. So 6 and the 1/6 cancel. And this left side is just 2 raised to the 1/6. Now be very careful with your calculator that you don't do 2 raised to the 1 and then divide by 6. You're raising 2 to the 1/6, right? And that's going to be 1.122 is what my computer is saying, okay? We're going to subtract 1 and we're going to get r equals 0.122. So that's about 12.2% is what we would need to get to double our money in 6 years. Be pretty good. Okay, let's talk about continuous now. Okay, here we're going to use PERT because it's continuous, right? That's the buzzword that you're going to be looking for. And we want to know, again, how do we double this initial 1,000 in 6 years? So the t would be 6. So I'm going to write this as 6r, not r6. Okay, again, divide by 1,000. And we'll be left with something that looks like this. And then we're going to take the natural log of both sides. Now, you could take a regular log, but it would take a little bit longer. So we're going to take the natural log of both sides and talk about why. So the left side is just a number. Natural log of 2, you'd punch into your calculator, and that is 0.693. And then on the right side, right, we're going to move my exponent down to the left. I'll be left with natural log of e, which we already said, that's just 1. So we'll get 6r equals 0.693, right? And if we take 0.693 and divide by 6, right, then we get 0.1155, 116 we'll say. Okay, so 11.6% if we're compounding continuously. So there's a little bit different, and we need the continuous one to be a smaller rate than the annual one, which should make sense to us. Okay, so moving right along to 12. Okay, the population of a city is declining at an annual rate of 1.8%. If the current population is 480,000, when will the population be 350,000? So our obvious key there is that it's annual rate here, not continuous, okay? So we're going to want to think of this as, again, this formula. Okay, and we currently have 480,000 people, and we want to have 350,000 people, okay, and we're going to be searching for, we know the rate. The rate is negative 1.8, right, so minus 0.018, make sure you have the 0 here, right, and we're raising this to the t. We want to find out when this is true. Okay. Well, 350 divided by 480, that's 35 divided by 48, that's just 0.729. And on the other side, we're going to have, what is that? 0.982 raised to the t. How do we solve this? Well, we're going to take the log of both sides. We're going to take log 0.729 and log 0.982 to the t. Okay, when I take the log of both sides, that t comes downstairs. Right? When I'm solving for an exponent, we take logs of both sides. Okay, and we're going to be left with log 0.729, which is just a number, equals t times log 0.982, which is also just a number. We're going to divide by log 0.982, and I'm going to be left with something that looks like this. That is a calculator exercise where you just punch that into your calculator, and Mr. Perlis is typing that into his computer right now. And I think we're going to get 17.40 years. 17.40 years. That's fun. All right. Last set of problems here. 13. Okay, this is with a calculator. That's a hint. Log base 3 of 6. Log base 3 of 6. Okay, so what's the giveaway here? That we have a calculator. So we're going to say 3 to the x equals 6. And this might look like we think we can play with them nicely, but unfortunately we cannot, right? We can't do anything here. Can't do anything nice, okay? And if we think about why that is, right, because 6 isn't really a power of 3, right? It's 3 times 2, but that's not a power of 3. right? So we're going to say, okay, I'm going to use the change of base formula up here. Change of base, right? And that says that if I have log base b of m, that's log base m over, or log of m over log of b, base 10 for both of them, right? So I know this one is just going to be bang log 6 over log 3. I know some of you are going to want to make that log 2. Please don't. Okay, and then what we know about this guy also, if we, so this is a totally acceptable answer. Well, you punch out in your calculator and tell me whatever that is. But if we didn't know to use change of base, right, we would take log of both sides because we're solving for an exponent, right? We would get x log 3 equals log 6, and then x equals log 6 over log 3, right? So you would get this answer. Which ends up being 1.63. Okay. So next guy, you do the exact same thing, right? Exact same thing, log base 5 of 7. Well, that's just log of 7 over log of 5. Done, right? Don't have to do anything fancy with this guy. And this is about 1.21. Okay. So just use your calculator for those guys. I'll do the challenges. Who cares? Okay, so the first challenge, we're going to have log of the cube root. X squared plus 21x equals 2/3. Well, that means 10 to the 2/3 equals the cube root of x squared plus 21x. Okay, I'm going to cube everything now. Okay, and I'm going to get 10 squared equals x squared plus 21x, or 0 equals x squared plus 21x minus 100. And then, of course, we're going to get x plus 25 times x minus 4 equals 0. So x equals negative 25 or 4. And actually, if you plug both of these in, I think they're both going to work. So I think we have two answers here. Okay, my other 14, love my numbering scheme here, looks something like this. Okay, and this one is tricky. Okay, we're going to multiply by the natural log of x minus 1. And now we're kind of stuck here, okay? And this is tricky to see, but we're going to want to take this x minus 1 here, and we're going to want to square it. We're going to want to, again, move this guy up into here, okay? So we're going to move that guy up into there, and we're going to say ln of x minus 1 squared. Well, now I have a natural log of something gives a natural log of something else, so I know that my somethings must be equal. So I'm going to get x plus 1 equals x squared minus 2x plus 1. And then if I move everything to the left, I'm going to get 0 equals x squared minus 3x. Right, we factor this and we get x times x minus 3. So x equals 0 or x equals 3. We'd plug them both in. If x were 0, we'd be in some trouble, right? Because I'd have negative 1 in the bottom. This would be negative 1. Right, so x is only 3. X is only 3. I'm not going to do my last one. There might be a similar looking like bonus-like thing. I hope this was helpful. Have